what will be the reading of the voltmeter which is connected across the resistance and the ammeter which is connected in the circuit. The circuit is given and the options are 300 volt 2 ampere, 800 volt 2 ampere, 200 volt 2 ampere. Fourth option is data insufficient. Now if you observe the question here, if we observe the circuit diagram, we see that the voltage across the inductor is 100 volts, the voltage across the capacitor is 100 volts, L and C values are not given. So maybe the student may think, for me to find the current through the ammeter, we may need the values of L and C. So maybe we may select data insufficient option. But we have to be careful and understand this question a little deeper. The voltage across the inductor is 100 volts and the voltage across the capacitor is 100 volts. That means VL is equal to VC, which means XL will be equal to XC, because we know that the same current flows through the circuit because it is a series LCR circuit. Therefore, we observe that the voltage across the capacitor and voltage across the inductor, because they are equal, XL is equal to XC. If XL is equal to XC, then this is the condition under which the circuit is in resonance. Because the circuit is in resonance, we can say that circuit behaves purely resistive. The circuit behaves as though there was only resistor. Now, keeping this idea in mind, it becomes very, very simple to solve the problem. So, the applied voltage, which is 200 volts RMS value, will be completely available across the resistor. Therefore, the voltage across the resistor becomes 200 volts. Therefore, the voltmeter will measure 200 volts. Current is nothing but voltage by resistance. So, 200 volts divided by 100 ohms, therefore 2 amperes of current will be the right answer. So, 200 volts and 2 ampere will be the correct option. This we can do it mentally itself. However, if you want to solve it using an equation, we know some equation here. The total applied voltage V is equal to root of VR square, the voltage across the resistor whole square, plus VL minus VC square. Now in this particular question, VL, the voltage across the inductor is 100 volts, the voltage across the capacitor is 100 volts, therefore VL is equal to VC, which is equal to 100 volts. Therefore, if we substitute this value in the equation, V becomes equal to root of VR square plus 0. Therefore, root of VR square will be VR. So, we get that the voltage V is equal to VR. V is nothing but the applied voltage. Therefore, the value is equal to 200 volts. So, we observe that the voltage across the resistor is same as the voltage which is applied. So, we got the voltage across the resistor. So, the voltmeter will measure 200 volts. Now, to talk about the current through the ammeter, we know that current is equal to voltage divided by impedance Z. And we know the formula for impedance, which is nothing but R square plus XL minus XC the whole square within the square root. But in this particular problem, we have seen that the voltage across the inductor is equal to the voltage across the capacitor, which is equal to 100 volts. Therefore, XL will also be equal to XC. Thereby, XL minus XC will become 0. Therefore, I is equal to V divided by root of R square, which is R. Now, the problem becomes very simple. I is equal to the applied voltage is 200 volts divided by the resistance, which is 100 ohms. Therefore, the current through the circuit is indeed 2 amperes. Therefore, the correct answer is 200 volts and 2 ampere, which is the third option. Dear student, now we are going to see another question from the chapter on alternating currents. An alternating current is given by the equation I is equal to 3 sin omega t plus 4 cos omega t ampere. Then the RMS value of the current will be. Here, this question, if we observe carefully, it doesn't appear to be in the standard form. The standard form is I is equal to I naught sin of omega t plus phi or I naught cos of omega t plus phi. Here it is a function, linear function of 3 sin omega t and 4 cos omega t. Now directly we may not be able to say the value of RMS, but we can transform it to something which we already know. We can take some effort to make it into the standard form, which is I is equal to I naught sin omega t plus phi or I naught cos omega t plus phi. Let us observe, children. Now here, suppose I divide and multiply this equation on the right hand side by 5. How did I get this number 5? The number 5, the hint is the coefficient of sin omega t is 3, the coefficient of cos omega t is 4, square root of 3 square plus 4 square, we will get root of 9 plus 16, which is root 25, which is 5. That number we are going to multiply and divide. There is a reason behind it. Now we are going to discuss that. Okay, children. So first we will multiply the equation, both numerator and denominator, by 5. So we will multiply and divide by 5. So 5 into this, the denominator 5, we will take it into the equation. So this becomes 3 divided by 5 sin omega t plus 4 divided by 5 cos omega t. Yes, children. So after we multiply and divide by 5, this is how it looks. Now, what is the benefit of writing it like this? Children, let us draw the triangle and use a little bit of trigonometry here. Suppose I have an angle phi here. This will be termed as the opposite side and this will be the adjacent and this would be the hypotenuse. Now, suppose I take the opposite side to be 4 and the hypotenuse to be 5, we know that this side, which is the adjacent, will be 3. As you know from Pythagoras theorem, 4 square plus 3 square will give you 5 square. Now what is the benefit of drawing the triangle and marking these values? Children, when we observe 4 by 5, we can take this as sine of some angle phi. 4 divided by 5, opposite by hypotenuse. We can take it as sine phi. So this can be written as sine of some angle phi, for which the opposite side by hypotenuse is 4 by 5. This is cos omega t. Now, the moment we write sin phi as 4 by 5, then cos phi, if you observe this triangle, cos phi is adjacent by hypotenuse, which is 3 by 5. Therefore, 3 by 5 becomes cos phi for us. So therefore, here 3 by 5 can be written as cos phi into sin omega t. Now the moment we do this, it takes a form sin omega t cos phi plus cos omega t sin phi. This is a known identity for us in trigonometry. Sin A cos B plus cos A sin B. Therefore, we can write this as sin of A plus B, which will be nothing but sin of A. In place of A, we have omega t. In place of B, we have phi. So therefore, this equation can be rewritten as I is equal to 5 sin omega t plus phi. Now, this appears to be in the standard form, which is I is equal to I naught sine omega t plus phi. Now, I naught is equal to 5. And we know that I naught is nothing but the peak value of the current. We are not asked I naught, but we are asked IRMS. IRMS and I naught are related to each other by the formula I naught by root 2 is equal to IRMS. Therefore, I naught become equal to RMS IRMS into root 2. Or basically we need IRMS, therefore we can plug in this particular formula, which is equal to I naught is 5 and divided by root 2. So we get the answer for IRMS, the RMS value of AC current, to be 5 divided by root 2 amperes, which is available in the third option. So dear students, in this particular question, we need to convert it from a form which is not in the standard form to standard form, for which we will make use of trigonometry. I am going to also give you a shortcut now for this sum. If in future you see a question like this, you can also do it by another quick way, where the moment current is given as an expression like this, then you look at the coefficients, then square root of 3 square plus 4 square, that value will be root of 9 plus 16, which is root 25, which is 5. That value directly will be I naught. So the moment you get I naught, you know that I naught by root 2 is RMS value. Therefore, 5 by root 2 can be arrived even without doing this method. That is going to be the shortcut for this particular question. So you will immediately arrive at the C option. Dear student, let us now look at another interesting question from this chapter. A coil, a capacitor, and an AC source of EMF 24 volts RMS are connected in series. By varying the frequency of the source, a maximum RMS current of 6 ampere was observed. If this coil is connected to a battery of 12 volts and resistance 4 ohms, the current through it will be. So here we are talking about two circuits. Now let us first draw the first circuit. The first circuit is a series circuit of a coil, a capacitor, and an EMF. Now the EMF RMS value is 24 volts, and it is connected in series with a capacitor. When I say coil, it is a combination of resistance and inductance in series. So this is how the first diagram is going to look like. Now here the question is, 24 volts is the EMF of the source, and very important point in this particular question is that it is given that a maximum current of 6 ampere was observed. The moment this word maximum comes, students, we must realize that the circuit is in resonance, because the current will be maximum when the circuit is in resonance. And you know that when the circuit is in resonance, the inductive reactance and the capacitive reactance are equal. XL is equal to XC. Therefore, although the circuit has resistance, inductance and capacitance, it will behave like a purely resistive circuit. Therefore, students, we can understand that the voltage across the resistor will also be exactly equal to the voltage which is applied, which is 24 volts. Therefore, the voltage across the resistor is going to be 24 volts, which is indeed the applied voltage, because the voltage across the capacitor and voltage across the inductor are going to cancel each other. Therefore, the voltage across the resistor is going to be 24 volts. The current through the circuit is 6 ampere. Therefore, I is equal to 6 ampere. Now, from this information, we will be able to find the value of the resistance. We know that from Ohm's law, R is equal to V by I. Therefore, V is 24 and I is 6. Therefore, the resistance of the resistor is going to be 24 by 6, which is 4 ohms. Now, we have found the resistance of the resistor using the concept given in the first circuit. So, the important point once again is that maximum RMS current is 6 ampere. The current is maximum when there is resonance in the circuit. That is the important point to be remembered. Now children, now let us go to the second circuit, second part of the question. If this coil is connected, so this is our coil, as I told you before, coil is the combination of resistor in series with inductor, and that coil is connected to a battery of EMF 12 volts. So the EMF of the battery is 12 volts, and not only these two, you also have another resistance which is of 4 ohms. Now all the three are connected in series. So R is equal to 4 ohms. Now the question is, what is going to be the current through this circuit? Now we need to understand one thing. Here we had an AC circuit. The applied voltage was AC voltage, and we know that inductive reactance is XL, and XL is nothing but L into omega. Now, if you observe here, what will happen to the inductance or inductive reactance? If you see, inductance L is the same, but if you observe here children, XL is equal to L omega, but for a DC source, a battery of EMF 12 volts, for a DC source, you know that the frequency is 0. So the frequency of a DC source is 0, therefore omega value becomes 0, therefore XL is equal to 0, which means inductive reactance is 0 when you connect this in a DC circuit. Therefore students, this inductance will simply behave like a short circuit. So if I redraw the circuit once again, we are going to have this resistor, and then this inductor will become a short circuit because omega is 0 for a DC. If omega is 0, XL is 0. If XL is 0, inductive reactance is 0. Therefore, inductor will behave like a short circuit. It will not offer any impedance. So therefore, we draw the remaining part of the circuit where we have this resistor, which is 4 ohms. And we found the resistance of this coil also to be 4 ohms at resonance. Therefore, we have this 12 volt battery here. Now the circuit simplifies into something which is very simple. For solving this, it is very easily we can use using simple concepts in electric circuits. Now if you see, what is the total resistance here? These two resistors are in series because they are connected in series. The same current is going to flow through both the resistors. So you know that the effective resistance is going to be 4 ohm plus 4 ohm, which is 8 ohm. Therefore, the effective resistance of these two resistors which are connected in series, because the current is flowing through this resistor, will be the same as the current flowing through this resistor. There is no branching of current here. So RS will be equal to 4 plus 4, which is 8 ohms. And voltage is 12 volts. Therefore, the current through the second circuit I, again given by Ohm's law, V divided by RS. The applied voltage divided by RS, which is going to be equal to 12 divided by 8. 12 divided by 8 is 3 divided by 2, which is nothing but 1.5 amperes. Therefore, the correct answer for this question is the second option.